Okay, good morning, everyone. Do you have any doubt or clarification from the last class? Actually, I forgot to upload the videos. I'll do it today with today's recording sessions. Uh, Still, do you have any questions in the previous session? Okay. Okay, so we will continue with the other transformation. Okay. Um, and whenever you get a time, please explore on the GitHub. So few of them might already know. So basically, so GitHub will be one of um the code repository the used in the market. Uh, so Git is a version control system, right? So that will be one of the version control system which is adopted in the recent days. So I would request people go and explore about Git if you are not aware. If you are know already, then it's fine. Okay, so I want everyone to get familiar with the Git. Okay, so that will be one of your uh, kind of prerequisite for your at least in the recent IT industry. Okay. Fine. So let's go back to this. Yesterday we saw a group by key. Okay, so basically, if you have a key value pair RDD with the key value pair, uh, we can actually do the aggregate based on the key using a group by key. Okay, so we saw how to do it. Now there is an extra submission called reduce by key. Okay, so group by key and reduce by key does the same thing. Okay, so if you have already of key value pairs, okay, so you can actually aggregate the value based on a key. The only advantage you get reduced by key is uh, so you prepare a key value pair and you want to do aggregate, right? So the aggregate done in the reduce by key aggregate will be kind of done in the reducer level. Okay, means the partition level aggregate also will be done. Okay, which means uh, passing the all the key value pairs to the final reducer will be minimized. You can think of as a when you use reduce by key, the combiner logic is applied. If you want to correlate with the map reduce, so whenever we write a map reduce job, so we do all the transformation in the mapper map function, and then finally we send the intermediate output of map method to the reducer. So if you want to perform say aggregate, so anyway, the reduce function will perform aggregate. So all the key values will be passed to the reducer. So if you want to reduce the number of key value pairs passed to the reducer, so we apply a combiner, which is kind of mini reducer. So which actually does the aggregates on the map output of map method, so that you will reduce the number of key value pairs passing to the reducer. So similarly, when you use a group by key, you will actually pass all the key value pairs, irrespective of the same key available in the same partition, you will pass it. When you use the reduce by key, the number of key value pairs will be reduced because it will do the aggregate in the same partition itself. Okay, if you want to visualize that, I can show you. The diagram is there. If you look at here, almost same thing we are doing it. So we have a key value pairs, right? So example, there is a letter A, which is we just key value pair A is a key and value is a 1, and B is a key and value is 1. and we have another. This is one partition. This is another partition. You can think. A is one, A, B, B, like that. So when you say apply a reduce by key, so there is a similar keys here. So this will be aggregated in the same partition. Okay. After that only the data will get shuffled. It will come to the final reducer to get the final output. Okay, so so basically when you use a reduce by key or group by key, the key value pairs will get shuffled to the final output. Okay, but when you use a reducer compared to a group by key, reduce by key, will try to minimize the number of key value pairs passing to the final reducer or final output. If you look at the group by key for the same input, so you see this is here you don't get aggregate here. It just passes all the key value pairs to uh, uh, the final reducer to then it will go and apply the aggregate function. I hope this diagram is helpful to understand the difference between group by key and reduce by key.
So reduce by key performs better than group by key?
Yes, group reduce by keys perform better. It gives you good performance than the group by key.
Okay, so if the this one, right, if the partition is one, then ideally both are same, right?
Ideally both are same, correct. Okay, so how do you use that transformation? So basically, again, I'm taking RDD of string and converting RDD of string into RDD of key value pair using a map transformation. We know how to do this. Then we apply the reduce by transformation. So what happens is you take when you say reduce by key, so the grouped values will come as a the grouped values you will get. So basically, and then you so a comma b is nothing but basically you're taking each element of values. So you just combine here. So it's not a and b are not keys. They sorry, key and values. They are the values. Okay, so I think I mentioned the previous one.
This lambda is
a Python.
Python function, right?
Yeah, it's a Python function.
So it takes two parameter and just sum it and give, right?
Yeah, so basically, when you apply a reduce by key, you achieve the key. The reduce by key function will take the function, right? So your key will be combined, means the group. You will get the values like this. The 3 is occurring 1 and 5 is occurring twice, right? So you get this 2 value. And if say example, if I just add one more time, you will get
one more. Then that reduce by key lambda function, can it be a, b, c, and it can return a plus b plus c?
It cannot be. It's basically it is nothing but it's going to iterate each like that. It's not A, B, C like that. So it's basically it will give you the each elements.
So it takes two parameter, right? I mean, simply it's a function which takes two parameter and sum it and give it back, right?
Yeah, correct. So each value will be sent and it will sum up and give you. We run this. Yeah, so 1 is thrice is occurring and 3 is once and 5 is two times.
Okay.
Okay, so this will yeah, and finally we are just collecting it using a collected action operation. Okay, so before we go into the next transformation, which is aggregate by key, so there is a so we saw a set of transformation till now, right? So basically from map and a flat map, we saw union, intersection, distinct. Now we saw group by key and reduce by key. There are two broad category of transformations. So we have RDD operations, two category. One is the transformation and actions. So in the transformation itself, we have two categories. One is the narrow transformation, another is the wide transformation. So what is meant by narrow transformation? So basically, narrow transformation, there won't be uh, shuffle between data. Means there won't be a shuffle operation applied on the narrow transformation. So when you look at the filter, okay, so I have a two partition or three partition. Okay, so when you apply a filter operation, say example, it goes apply the filter operation on the partition one. Say I have five values in the partition one. So if the based on the filter condition, only two is matched. So from the partition one, out of five, two will be given. And similarly, if you have other transformation which has 10 values and matched values are five, so it is going to give the five values. So it just filters the data from the partition that give it back the RDD. So RDD is going to have the RDD of same two partition with the what are the values it matched. So there is no uh, data which is getting shuffled here. Okay, that is generally those type of transformation called shuffle transformation. Sorry, narrow transformations. Whenever you see the data which is getting shuffled, so in case of reduce by key and group by key, those transformation called wide transformation. So if you want to show you the um, so narrow transformation, you just take a value, you take a partition and you apply some value and you get that out of that values from the partitions, you might get one or multiple values. Okay, so those case you will not a shuffle will not happen. Uh, then the wide transformation, you will the data will be shuffled between the partitions. Okay, so this is one of the important things to note. Whenever okay, so let's show you one thing here. I think we can take this. Uh, okay. We'll apply this to the input. We'll just split it to this. just to stop at this location, I'm just putting an input function. I'm calling input function. So I'll run this. We'll just go and just see the Spark Web UI. Go here. So Spark Web UI, if you are running from just running from your local mode, you can actually watch it in the localhost 4040. Okay, so whenever you see there is a wide transformation, then you will see that actually new stage will occur. New stage will occur. Okay, so basically, last session we tried to use multiple transformation, but there was only one stage was there, right? We were not able to just look at the different stages. We were see only one stage. So in your job, I told you yesterday itself, whenever you see a action operation, you will actually find one job ID, means one job will be created in your Spark application. Every action operation will generate one job, and in your job, every wide transformation will actually invoke or create a one stage. Okay, so the get stage will have a task based on the number of partitions you have. Okay, so yesterday. Okay, so whenever you find a wide transformation, you will see one stage, a new stage will be introduced. Otherwise, it will go with the one stage only. Okay, next we'll go to we'll explore on the. There is another transformation called aggregate by key. Okay, so till now we saw. So basically, there is a group by key, reduce by key, where we are trying to find out aggregation. We are trying to create aggregate function, apply the aggregate function, and get the result based on the key. So here you can get only one. We can actually apply one aggregate function. So here we can actually just do sum here, right? So if you want to perform, if you have a key value pair, you want to perform two different aggregation at the same time. I just want to do sum as well as the multiplication, or maybe count. Okay, so if you want to perform two different aggregations on your key value pair, then we will be using a aggregate by key transformation. So think as an example. I have an example. Say you have okay, you have some key value pair. Say example, you have a IPL team name CSK, and you can think of as a this one you can think points. You can think of as a points. Okay, so CSK has 3 points here, and here 2 points, and again here 3 points. Okay. Now you want to find out for each key, you want to find out the occurrence of, say example, if you want to find out uh, um, number of matches. So example, this considered each key value per represents one match. Okay, so if you want to find out how many match it played and how many points it got. So if you want to apply uh, that if your output you're expecting is how many number of match it played and what is the total number of points. So if you sum up, if you count the number of occurrences, you will give the number of matches. And if you sum up all these points, you will get the total number of points. So basically, you need to apply the two different aggregations here on the key value pairs. So then we can use the reduce by key, sorry, aggregate by key. So aggregate by key takes a 3 argument. One is the initializer, okay, and the next is a sequence function, and the third is a combine function. Okay, initialize is basically mostly it will be like it will 0 by default. And if you want actually, you can initialize it some other value. You can also initialize. Generally, it will be 0 because okay, so and here the sequence function. In the x sequence function, you when you say lambda of x comma y, the x represents the initializer. Okay, so just this is very important to note it out. In this lambda x comma y, x represents the initializers. So two initializer. This initializer is for sum of points, and this initializer for you can think as a the number of match in place. This we are going to do the we are going to find out like uh, number of match played, and this is for sum of points. So the x will have initializer values, these two values, and y is basically the value which is getting grouped based on a key. Okay, so this is what we are going to do. We are going to so as I said, x is basically initializer. X of 0 will give you this 0.0, and x of 1 will give you this 0. We for the count we just increment by 1. For sum we just access y. So it is going to, when you access y, it's going to get this values. So it will add. So for CSK it will add 0.0 with 3, and similarly for 2 and again 3. Okay, that is what you do it in the that will be done in this sequence function. Okay, and the combine function. So combine function basically this will give you the intermediate. This is I think at the intermediate level. Okay, so this will do at the global level. Okay, so I think it's partition level, within partition. Yeah, so this is going to give you at a partition level, and this we will be doing at the global level. Okay, again here we can think of as this is a this RDD is basically represents the sum up function, and this represents the count function. The count means count operations, values of the count, and this is going to have a values of summed value, which is for points which we are summing up, and this is basically the values of which performing count. So anyway, you have to do here sum only, because we just found already uh, the intermediates in the partition level. We already found the sum and um, sum of points and the sum of our match number of matches. So you just do the sum here. So RDD of 0, RDD of 0, and RDD of 2 of 0. No, sorry. So basically each RDD represents, sorry, partitions. So in the first position basically is for uh, um, first position for summing up your points, and the second position basically we are doing the uh, finding the count of number of matches. So this is going to give you the sum of points, and this is going to give you the number of matches. So you need to understand two things: the first argument initializer, and second argument is the basically the sequence functions which is applied on the individual RDD, and finally this is a global level aggregate. So if I run this, so you see here you use CSV. The points are 8 points. I guess 3 plus 2 5 plus 3 8, and so we counted number of matches, which is 3. So this is how you can, if you want to apply true aggregate function on a key value pair in RDD, you need to use a aggregate by key. All right. So okay, next is the next transformation will be a sort by key. Is very straightforward. You just say if you have RDD which is not sorted, and if you use sort by key, it's going to sort based on a key. So if you look at here key is in the number in a the representation of 3 in a number, and value is basically the character of 3. Okay, so if we and similarly this number representation and string representation, and if you just uh, sort by key, so now you have a list of 3 5 1 4 2. If I just sort by key, then you will have first position 1 2 3 4 5 9. So that's why you just use it's a simple very, you apply a sorting on the key which is available in your RDD. When I run this, okay, so you see here this was our input. Now after sort by key applied, then it becomes like 1 2 3 4. Okay, this is very simple. I'll just close this. Next is join. Again, so if you have a so if you have a 2 data set, which is like 2 RDDs, so we can actually perform a join operation between 2 RDDs using a join transformation. So RDDF1 join of the RDD2. Then so anyway, it is going to give the joined values. Then you can perform Okay, so this is basically when you use a join it, I think it is inner join. It is going to do the inner join. Okay, let me run this and show you. Okay, so it does the inner join. Basically, you see there is a 3 and 4 is left out because this two are not matching in the data set. Okay, so if you can use the uh, you can use the other join types. So we have right outer join, left outer join, full outer join. You can use those join transformation as well. So you have any doubt in this, the join operation?
Nobody.
Okay.
This lambda one still we are not able to understand how
Sorry.
lambda is used. This
Sorry.
lambda function. This lambda function.
Uh-huh.
I have difficulties in understanding how this is.
Okay. Okay. You can just
How it is getting used and how the parameters are decided.
see here. Okay, so what is the? We'll go to the map transformation. Where if at least map transformation, you here at least you see this. First you need to understand this one. If you understand this,
Okay.
then the
Okay.
things will be little clear. Oh, so that's what I actually did to okay. Okay, let's rewrite this code. Okay, almost it is already we are doing this. Me